Okay, so in this lecture, I'm just going to show you that how you will construct an operating characteristic curve or OC curve while using Excel. So as I already mentioned that you can construct an OC curve while using different discrete probability distribution, just like in my other lecture, in my previous lecture, I have already discussed that you can use binomial distribution, you can use hypergeometric distribution, and you can also use Poisson distribution. And in that lecture, I have already discussed in great detail that when you will be able to use binomial distribution, when you will be able to use Poisson distribution, and when you will be able to use hypergeometric distribution. So after watching that video, you will be able to identify that which data is good for the binomial distribution, when we need to use binomial and when we need to Poisson distribution. So in this lecture, I'm just going to show you a simple example that how you will sketch the OC curve. So as you people know that operating characteristic curve is a graph of the percent defective P in a lot of batch, the probability that the sample plan will be accepted in the lot. So we will check that when we will be able to meet the producer requirement and when we will be able to meet the consumer requirement, because there is some risk involved. And in my previous lecture, I already discussed the producer risk and the consumer risk. So from OC curve, we will be able to easily identify those specific zones, those specific region where there is producer risk and where there is a consumer risk. Basically, OC curve show you the probability of lot acceptance as a function of lot quality level, and it's based on the sampling plan. So I mean, from huge lot, you will pick randomly some specific sample size. For example, if you want to buy a container, that in that container there are, let's suppose, 5,000 mobile phones. So it will be very difficult to inspect each and every mobile phone, that is this every specific mobile phone is good or defective. So being a inspector, you will just take out a random sample. Let's suppose you only pick 100 mobile phones from that container. Now on the basis of that sample size, which is now n is equal to 100, small n is equal to 100, you will accept or you will reject. So basically we will sketch an OC curve, a curve which will showing us on the x-axis of that will be the defective probability, the defective chances, and on the y-axis it will be showing the acceptance probability. So basically this curve will help us to keep the high cost of inspection down, because while inspecting each and every, it's time consuming and you need a lot of money, you will spend a lot of money because you need to hire more labor. So that is why we need to use the acceptance sampling approach, and the basic acceptance sampling approach is the OC curve. So how you will sketch that? So this you can see from the figure, this is simple OC curve. So the proportion defective representing, these are the proportion defective probabilities, which is in the percentage, hundreds, and these are the probability of acceptance that you will accept. So mean on the zero mean this is 100%. It's mean that the probability of defective when it is equal to 0, your acceptance probability will be 100%. But when you going, let's suppose at 1% defective, your probability will be this one. Okay, it will be 0.9. At 2, the probability of acceptance will be further down. So when the defective proportion, for example, in those 100 mobile phone, when the number of defective increase, the acceptance probability will be decreased, because you will not able to buy that, because it will reduce the probability of acceptance. So at this way you will sketch this, the OC curve. So once again, XY represent defective, y-axis represent the acceptance probability. So as I already mentioned in the starting of this video, that means you will be able to construct OC curve while using binomial distribution, hypergeometric distribution, and Poisson distribution. So in my previous lecture, I already discussed that how you will sketch binomial distribution. This is the probability distribution function for the binomial distribution. N is the sample size, X. So mean 0 defect, or mean rejection rate, 1 reject, 2 defective, 3 defective. This is the probability of success and this is the probability of failure. This is the accepted probability and Q represent the failure probability. So this is the binomial probability distribution. Similarly, hypergeometric binomial distribution, each trial will be, you will consider that all are independent trial and trial will be fixed. Hypergeometric and binomial is different from hypergeometric, because in hypergeometric we will consider that the trial are dependent. The probability of one trial will depending on the other probability, other trial probability. So that is why binomial and hypergeometric are different in these two properties. That the number of trial will be independent in binomial and the number of trial will be dependent in hypergeometric. Poisson is another probability distribution which is also a discrete probability distribution. We can also call Poisson distribution a limiting case of binomial because all the properties of this are same. So in all these distributions there are only two possible outcomes: accept or reject, good or bad, alive or dead. Okay, so when there are only two possible outcomes, so you can use these three different discrete probability distribution. The Poisson distribution, as you people know, you can also write it NP because this is lambda power R, and R represents the defective, let's suppose. So NP because lambda probability, lambda is the mean of Poisson distribution. This is the mean of Poisson distribution, and lambda is equal to NP. Now I'm just going to show you that how you will use Excel in order to construct a binomial distribution, in order to sketch OC curve and then interpret the orientation. So you can see from this Excel sheet, we have some defective probabilities which start from 0, 0.01, 0.02, 0.03. Similarly, this is the probability. For example, in that, let's suppose we have a container. We want to buy that container. We want to accept to buy that container, or we not need to buy that container. Let's suppose there are 5,000 mobile phones in that container. So it will be very difficult to check each and every individual mobile phone. So what we will do, we will take a sample. This is sample now. We just taking randomly 120 mobile phone. Our criteria of acceptance, let's suppose, we will accept the whole container. In this example, lot is the container. So we will accept it if there are only two reject. In those 120, we will accept the container. We will buy that container if in 100 if there are only two defective occur. If we get 3 defective, we will reject it. We will not buy this container. Okay. So our criteria of rejection is greater than 2. If the defective mobile phone in that container are greater than 2, we will not buy it. But if it is 0, it means 0 means no defective. If it is only 1 defective, it's okay. We will still buy it. If there are 2 defective, we are still buying it. But if the number increase from 2, then we will not be able to buy it. So this is when you add all these, you will get the cumulative distribution function, which I will show you. So in order to construct the Poisson distribution, in order to construct an OC curve, I'm just going to show you that how you will sketch this. So as you people know, this is mean the defect. So these are the probabilities. We just transform this into 100. So how you will calculate this is equal to this into 100. So we just transform this into the 100%. So you will drag it down. So you can see it multiply by 100. This is my sample size. So our sample size, the random sample which we took from the container. So these are same. Now we need to calculate NPR. You can also say lambda. So lambda. Okay. So how we will calculate N is equal to P? So you people know the formula. N, this is into the probability. So in this way we will calculate the probability. You need to drag it down. So these are our probability. Now we need to calculate Poisson distribution. So is equal to, you need to write Poisson. This is Poisson distribution. You can see Poisson distribution. So now in Poisson formula you can see X. So what is your acceptance criteria? X represent the number of number on which you will construct a threshold, that above that threshold you will reject, below the threshold you will accept. So in this example this is 2. So I will put 2 because we want to keep this constant. So you need to press F4. F4 will do, it will keep it freeze, it will keep it constant. Or you can manually put the dollar sign from before the K sign and after the K sign. Okay, comma. So you can see now it's showing the mean. So what is mean? Now you need to calculate, we already calculate the mean, and mean is this one. So we just put this mean. Okay, then again comma, comma, then cumulative I'm just going to show you what is cumulative distribution. So we want to construct a cumulative distribution. That what will be the possibility to accept this lot. So put 1 or just write true. So you will be able to construct a cumulative distribution. Then okay, close it. When you click it, you will construct the probabilities. Okay. So how you will calculate this cumulative? So you can easily calculate these cumulative probabilities. For example, for this one, I am just going to show you that how you will construct this, how we get manually if you want to use Poisson distribution. So you people know that lambda is equal to NP is the mean of Poisson distribution. Probability of x is less than equal to 2 mean, probability of 0 plus probability of 1 plus probability of 2. Our lot will be accepted for this case. So this is cumulative distribution. So x is 0 for 1, for 2, our lot is accepted. And you people know the cumulative probability distribution is e power minus lambda power x factorial. So when we put lambda is equal to NP, in this example, my p is 0.01. So this is my p, which is 0.01. You can see this is 0.01. And the Poisson distribution, the acceptance probability, these are basically the acceptance. These are the acceptance probability. Okay. So you will calculate the acceptance probability at this way. E power lambda 120 into 120 into 0.01. We will calculate mean 1 power minus 1.2. Then again 1.2 power 0, because we want to calculate when there is 0 defect. So 0.30 when x is equal to 1, when there are only 1 defect. So e power minus 1 over lambda. You just put the lambda value in this, 1.2 power 1. Now x is 1 divided by 1 factorial. So we will get 0.36. E power minus 1.2 into 1.2 power 2, because x is 2 now, and divided by 2 factorial. 2 factorial means 2 into 1, so 0.21. When you add this whole, so you will get cumulative probabilities. So summation px only for this case, the Excel already calculated while using this formula. Okay, so 0.879. So manually you can easily calculate this. Similarly, let's suppose p is equal to 0.02. So now what you will do? Lambda is equal to 120 n into p. So 120 n is same because we took this sample size, n to 0.02, so it will be 2.4. So e power minus 2.4 into 2.4 power 0 divided by 0 plus 1. So when you sum all these probability, you will get the cumulative probability. So you can see 0.56 and this is 0.56. So at this way you will calculate all these. Now I'm just going to show you that how you will construct. So just select this one and how you will sketch this the OC curve. So click this insert. Now we want to sketch this. So this is my OC curve. In OC curve we also want to add axis. So this is my defective probability. So you can defective probability, and these are the acceptance probability. So you can write acceptance probability. So you can see that 1 mean at 0, when there is 0 defect, there is a chance of that you will accept the lot 100%. But when the defective probability is going increase, okay, this is now 2%. So in this case, there is a chance that there is 0.59% chance that you will accept this lot. So at this way, you will construct this OC curve. Now, I hope that you understand how you will construct an OC curve while using the Poisson distribution. Now I'm just going to show you that how you will construct a binomial distribution. So you people already know that the binomial distribution function is e power. Sorry, this is not the binomial probability distribution function. The binomial distribution function, probability distribution function is n of x, p power x, and q power n minus x, where p is the acceptance and q is 1 minus p. This is rejection. Okay. So now this is the same question. We want also to construct the defective, because the defective probabilities are given to us. These are our sample size from the lot there is 5,000 mobile phone, and n is the sample size. We only took this one, and we will reject this whole lot if there are more than 2. So more than 2 mean x is less than or equal to 2 mean 0, 1, 2. If 2 mobile phone are defective, 1 are gone, so we will accept this. Otherwise, we will reject this. So now we need to construct a binomial. So in binomial, you need to write this formulation. How you will construct? So if you check this formulation, it is very simple. Then you will be able to construct. So I am just going to write this again for you. Okay, is equal to binomial. So binomial distribution is already here. Now number s, how many? What is criteria of rejection? When you will accept the lot and when you will, so if there are more than 2, we will reject it. Okay, this, so number s, trial, how many trial, comma, the number of trials, so there are 120, we took sample size 120. Once again, you also need to freeze it. So for freezing, you need to press F4 or put $ before the alphabet before and after. Okay, then the number trial, now the probability, so now the probability, so we already put numbers, trials, probability, so this is the probability. Okay, then comma, then we want to construct a cumulative distribution, just like I already discussed it. So yes, we also want to construct a cumulative distribution. So you can also construct a cumulative probability mass function. So just put it, and in this way you will calculate the whole probability distribution. If someone is interested, if they want to calculate it, for example, for this value, if they want to calculate it for 0.01, so you people know that x is equal to 0, 1 and 2, okay, and nx, px, q power n minus x. So now the probability p is 0.01, so q is 1 minus 0.01. So q is equal to 0.99. So now n is 120. So 120, x is 0 because x value is 0. Probability is 0, p power 0.01, x is 0 and q is 0.99 power 120 minus 0. Similarly for this one, 121, 0.011, 0.99, 120 minus 1. And similarly for this one, 0.01 power 2, 0.99, 120 minus 2. So when you add this, you will get summation px, and these will be the cumulative distribution, and the value will be 0.8803. So you can see this value. 0.88036. Similarly, for this probability, you will calculate this cumulative probability binomial distribution for this. So now you need to sketch the curve. So select this one and this one. So how you will construct a OC curve? So OC curve we will construct. This is the OC curve. So you can also add x stable if you want. This is the defective, and these are the acceptance probability. So acceptance probability, and this is the defective rate. So you can see as the defective rate increase, the acceptance probability decrease. So in this way you will construct the binomial distribution. So I hope you understand. Now in my next lecture I will show you that what is acceptance quality level and what is rejection quality level.